Okay, so this should be it. Am I audible now? Can you guys confirm if I'm audible? Hello? Yeah. All right. So we'll just wait for another 2 minutes. Meanwhile, if you guys have any doubts or if you guys want to ask anything, we can just drop a message on the chat or we can talk about that as well. Okay, great. Okay then. It's almost 4:59, so I think it's almost like 1 minute for five. So let's get started, guys. So meanwhile, people will join. So today, what we'll be doing is we'll be doing basics of Solidity. So we'll just learn about basics of Solidity so that we can start with the contracts and everything from tomorrow. So this will be a very quick session for you guys. So here, let me introduce you to Remix IDE today. So you can go to Google, okay, and then type Remix IDE, and then this will give you a link, remixproject.org. You can go to that, and then here you can see you can have this Remix IDE right here. Just click on that. Okay, so this will get you to the Remix IDE. So Remix IDE is basically like an online code editor, like IDE. What do you mean by IDE? Integrated Development Environment, right? So it gives you this environment online. You don't have to install anything or you don't have to set up anything. If you just have a browser and a wallet, that's fine. Even if you don't have wallet, that's also fine, because Remix has their own VM as well, okay, which provides you with the test accounts. Okay, so Remix gives you this online ID environment where you can debug and develop your contracts, Solidity contracts. So today we'll be creating we'll be just writing a simple contract. We'll be learning about data types, we'll be learning about functions, we'll be learning about access specifiers, on most of it. Okay, so here let's learn about what is this Remix here. So you can see we have this home page where it gives you some features and information about Remix. And then you can see here we have the project tab where you can see all the list of files and folders. And then similarly have some of the icons here. If you click on that, you get to search, you get to compile, you'll go to deploy panel, you go to debug panel. I don't know what's this though. I think this is some type of statistics. Yeah, stats about a contract. And this is testing. So basically you can do most of things on Remix IDE. Remix IDE allows you to do many things here, like writing test cases, debugging, seeing basically profiling, like how much of gas is your function is using, how is your function running, or how is your contract basically performing and everything. So now let's start writing a simple contract. So we'll go to I have a workspace creator called Duo. So if you want to create a workspace, you can just go to click on this plus icon and then just give a workspace name. I'm gonna just cancel this right now because I already have multiple workspaces. I just don't want another one. Okay, so we'll go to contracts here, and then we'll just write one more simple contract. So I'm gonna just right click, new file. I'm gonna say 10 underscore sample.sol. Here the file name can be anything, guys. Okay, you can have anything as the file name, but .sol is really important. Okay, you should make sure that .sol is available, and 10 underscore sample, it's up to you. I just follow this standard which Solidity is already following, Remix ID is already following, so it's up to you guys. Okay, all right, now we're back in the code. Let me zoom in a little bit more for the code. Great. Okay, the first thing that we write in Solidity smart contract is we define the version of which which version of Solidity we want to use. So here I'm going to say pragma solidity 0.8.2. so here I'm using 0.8.2 version, and it's up to you guys. You can use any version you want. The latest version is I think 0.8.17, but you can use any version of contract you guys want. Okay, now the next step what we have to do is we have to define the contract. So we say we start the contract, or we define the contract with the contract keyword followed by the contract name. So let's say we'll say sample here. Always it's very good to good practice to follow start the contract name with the capital letter, okay, the uppercase letter, okay, and then here, and then open up braces here. So now you can see the contract is created. So basically the contract is ready. Okay, the contract is created. You don't have to do anything right now. Okay, so even if you deploy this, your contract will be ready. Okay, but the only thing is you won't be having inside, you won't be having anything inside. It's just empty. Okay, now what we can do is let's define some variables. So in Solidity you have many different data types, such as your normal programming language does, like your Java, JavaScript, Python and everything, like string, numbers, boolean, etc. So let's say how to define a string. So you just say string, and then let's say greet equals hello, good morning. Oh, it's evening, right? So we'll say evening. Okay, but this actually won't work. Okay, this is actually this is fine though, but it's always best to say where do you want to store the string. Let's say in memory. Okay, wait, there is an issue. I don't think we need to specify this for strings, but that's fine while defining a variable. But I'm going to just talk about what is memory and everything. I think we have to specify that on numbers, in functions. So now what's the next thing? Let's say how to define an integer. In integer you have two things. You can either define a signed integer or you can define an unsigned integer. What is signed and unsigned? Unsigned, in a sense, unsigned says that you can have both negative and positive numbers. In signed you can only have positive numbers. Okay, so to define an unsigned integer you go with uint. Okay, this is how you can define an unsigned integer, and you have to specify the size as well. So you can say 8 or 16 or 32 or 64 or 256. Okay, if you don't know which size you have to specify, just go with 256. Okay, and then here let's say num equals 1. This is fine. Okay, and let's define a signed integer. Let's say int 256 num signed equals 2. Semicolon is necessary. Let me say I have -1 here. Nothing's gonna happen. Oh, 1 second. Oh, well, maybe we cannot directly use it like this, so we'll just remove it. Okay, so let's say now let's talk about boolean. So let's go to bool, and let's say is raining, and let's set it to true. Okay, of course it's not raining now, so I'm going to set it to false. Okay, cool. Now so these are the like basic data types in Solidity. Okay, now let's look at functions. And functions, you have a couple of things that you have to take care of. One is define, of course you define the function with function keyword, but there's one more thing that you have to take care of. That is you'll add the function name. Of course, let's say greet users. Let's say call greet users, and then I'm gonna just open the braces. Here everything is cool, right? The function, we have the function name, we have the parentheses and everything. That's cool. But what is the one thing that is missing here? The one thing that is missing here is we're not telling Solidity how to handle this function. Meaning, in what I mean here is, I'm not telling Solidity what I want this function to be. Whether I want this function to be visible to users, whether I want this function to be secured, not visible to users, or do I want this function to be only used inside the contract, or do I want this function to be visible, but do I want this function don't want any other function to use this function. So there are a lot of these edge cases, right? So I have to specify what exactly is my goal when coming to the usage of this function. So let's say I say public. So let me say I say public. If I specify public here, then this function can only be used by outside people and internal contracts. Okay, internal context can use this since it's public, and outside people can also see this function. They can also interact with it. So what if you do this internal? So when you say internal, as the name suggests, no other functions can use this. Okay, only internal functions can use this. Okay, only internal functions. And there's one more access these are called access specifiers. Okay, there is one more that is called external. Okay, when you say external, only outside people can use this. No like internal functions can use this. So let's say I have one more function down below here. I cannot use this greet users from that. Okay, it will throw an error. That's what external is. Okay, so now let's just return something. So let me return greet. So now we can see this won't be accepted. It's throwing error. So here you can see greet error. It says different number of arguments in return statement than in returns declaration. So it's saying that I defined a function. Okay, I specified the access specifier here, but I didn't say what type of value I'll be returning, what type of data type I'll be returning. So here we're returning a string. Greet is a string, right? We're returning a string, but I didn't tell Solidity while defining this function that I'll be returning a string. So that's one of the necessary things. So what we'll do is we say returns and we'll say string. Okay, and this is not enough. I have to specify memory here. Memory. Okay, now why is this memory? Right? Why is this memory? Why did I specify this as memory here? What does it do? So basically what we're telling Solidity is when you return this string, store it in a memory. Okay, because Solidity has to store it something. I mean, so function has to store it somewhere while returning. Or let's say you are trying to compute something, so it has to store it somewhere. So you have to specify where you have to store it. You have two options, memory or storage. You can also specify storage here. Okay, both works, but memory is very cheap because you won't be actually storing that on the hard drive. You have to store it in memory while returning. Okay, while returning. So or else let's say you accept a string here. Let's say you accept a string name or something here. Okay, and if you put this as storage, it's fine. Okay, but if you put this as memory, it's also fine. When you put this as storage, you're actually storing it in a hard drive. Okay, hard drive of the what do you say, EVM. Okay, so if you put this in memory, then you won't be storing it in hard drive, but you'll be storing it in a RAM. Okay, it is like what is it, temporary. It will be erased. Okay, sooner or later. So for now we don't need this one. We'll just remove this. Can remove that. Come back, and also we have one more warning here. The warning says it should be a view function. So you can see function state mutability can be restricted to view. So what does that mean is, if you observe this function, we're not modifying anything, right? I'm not updating anything. I'm not writing any data. I'm not updating any of these variables or anything. So Solidity is suggesting us to make this as something called view. So what is view? So view function specifies that this function is dependent on some other data outside the function, but it's only readable, meaning that it's not updating anything. It's only read only. Okay, so you can see here, right? I'm dependent on this greet variable which is outside the function, but I'm not updating anything. So that's what view is. And view is gasless. So remember the gas that we discussed in the first class. So view doesn't charge you any gas. It's free. Okay. Similarly, there is one more state mutability that is called pure. So let's say sum and accept uint 256a and uint 256b. This will be external as well. Return a plus b. I have to specify returns. Return will be uint 256, and this would be pure. Why is this one pure and this one view? Because if you can observe this second function, you can notice that we're not dependent on any other variable, right, outside this function. I'm not dependent on any of these variables. I'm not dependent on this function. All I'm being dependent on is the value that I get from this function, right? So again, I'm not updating anything as well. So I just compute the sum. I just sum the amount a and b, and then I return it. So no matter how many times you call this function, it is not dependent on any other variables. So this is called pure. Okay. So similarly, we can have one more function. Let's say update greet. Okay, or update num. Or I think it will make more sense if you say update raining status, since we have is raining over there, and we'll accept a boolean status. This would be external. This would not return anything. This would not return any function or anything. So, and then what we'll do is we'll say is raining equals status. Okay. Now we can see I didn't specify view or pure here because I'm actually updating something. I'm writing something to the chain, right? And we don't have any returns here because I'm not returning any data. Okay. So this is about functions and access specifiers and state mutability. So state mutability specifiers. So view and pure are state mutability specifiers. Okay, so this is one of the very important concept in Solidity, like in functions, because you'll be using this throughout your contract. Okay, if you're writing contract, let's say you're writing a contract, then you'll definitely be using all these things. These are like base things, fundamental things that you need while writing a contract. Okay, now let's look at one more data type that is called mapping. Okay, mapping. So you must be familiar with this thing called key value pairs, right? So that's what mapping is. So mapping maps a key to a value. Okay, so here let's say I want to store a key type of string. Okay, key type of string to a boolean type of value. Okay, here now we will say attendance something. Okay, now this attendance will accept a key of string of type string and a value of boolean, and you can get that boolean value with the key string key. Okay, now let's see how we can do that. Now we'll write a function. Okay, we'll write a function called get attendance. Okay, and this would be public. Now we'll just mark it as public, and this would returns boolean. Okay, and we'll accept a key here. This key would be string in memory, and this would be key. Okay, now what we'll do is we'll say return attendance of key. That's it. Okay, so now we can see, and since we're only reading data, we can mark this as view. Now that's how we can access it. So now I'm going to pass the key here, and whatever the value that is associated with that key will be returned. Now let's see how to actually update the mapping. So I'm going to say function update attendance public returns bool. Oh, we don't actually need returns boolean because we'll be updating. I will be always setting it as true, so no need to return that true back. So we'll say update attendance, and then what we'll do is we have to accept the key here. Again, string memory key, and then we'll just come here. We'll say attendance of key equals true. Okay, now we can see, since we're updating something here, updating the data, I'm not using any view or pure. It's just plain simple. Okay, so this is about mapping. So whenever I call this attendance, whenever I keep passing a new string to it, it will keep on storing them in key value pairs. So imagine the data would be something like this. So something like this, Pavan, and the value here would be true, and similarly it would be like Dev, the value would be true, something like this. It will be storing everything like this, And now if you want my data, if you just pass the value here, no matter if the record, if we have like this, if this mapping has like 10,000 data, it will fetch you immediately because it's storing key and value, right? So it can fetch the data automatically. Okay, so that's what mapping is. Now next thing what we can do is we can learn about modifiers. So let's learn about modifiers here. Modifiers, you can just say modifier and then we'll have a name for it. Let's say only let's say only teacher. Okay, only teacher. Now what we'll do is we have to accept let's say we will have an address here. Oh, I forgot about one more data type called address. So address is a data type which allows you to have store addresses. Okay, we'll say teacher here and then we have to store address. So let me get my address from my MetaMask, or let's just let's get it from Remix VM itself. So you can go to this fourth icon here and you can see we are in Remix VM. I'll explain what are all these things later. You can just copy this. Okay, copy this, come back here, we'll add require. Okay, and oh sorry, we have to paste this here. Okay, now we can see I didn't store this as a string, right? You can say I didn't store this as a string like this. Okay, because why? Because it's an address type. So address type is defined, or it is basically available to help you handle these Ethereum addresses. Okay, now we'll say inside modifiers, I'm just saying require, okay, teacher or msg.sender. msg.sender is basically it returns you the address of the current caller. So if I'm the one who's calling these functions, then msg.sender will have my address. Okay, so I'm gonna say msg.sender equals teacher. If this is false, then say not a teacher. Okay, if this is true, then return, just do nothing, just handle the process to handle the control to the next modifier. That's what we'll be doing. This will just do nothing, it will just return. Okay, so now how can we use this? So you copy this and you use it wherever you want. So let's say update attendance. Update attendance can only be updated by teacher, so we'll add it here. That's all. Okay, that's all. Now let's test it. So now for testing, let's go to compile tab, third one. If you go here, you can see it's 0.8.2, the same as our Solidity version. Click on, make sure the file name is correct. Come back to the fourth icon now. Since it is compiled, make sure there is no red warning here. Okay, only yellow warning is fine. Come back to the fourth icon. Here you can see we have environment. If you click on that, you get a lot of environment here, right? L2, external HTTP provider, and Ganache provider, hard hat provider, all these things. So what you can do is, for now we'll just select Remix VM, but you can also select MetaMask as well. You can select hard hat, Ganache, Foundry, or anything you want. So we'll let's just select Remix VM because it will be fast and we can also see the transactions running. So, and you can see Remix gives us around 10 accounts, 10 to 15 accounts here, which has 100 ethers each for gas. So now you can see here we got this sample contract as well. We'll click on deploy. So in a deploy, you can see the check mark here, meaning that it's deployed. Okay. All right. So now here you can see under deployed contracts, we have all these details update attendance, update training state. Update training status, get attendance, greet users, sum, and everything. So if I click on greet users, you can see we get hello, good evening. What is this greet users? The variable here. This is public by default. That's why. Okay, that's why we're getting it. I think I have to. What happened? wait, guys. I think I zoomed in a lot. Okay, I think it should be fine now. Yep. Okay, now coming back here. Oh, I think we have to deploy again. Yeah, let's deploy. I hope the teacher address would be same though. Yep, it is same. So now we can see we have sample here. We have update attendance, update raise, and greet users and everything. So now let's just try to, this greet users is a function, this function that returns a string. Yeah, here, greet users. This function returns a string. We have some. Let's just see what some outputs are. Let's say send 2 plus 2 comma 4. So we should get 6, and we got 6. Okay, if you click on this arrow icon, you'll get the individual boxes where you can send individual parameters, arguments to it. Okay, and then we have get attendance. So let's just try to send my name here. It should not work because of course we don't have anything here, so it should return false because we don't have the data. Now let's just update attendance. So I'm gonna say string key would be Pavan here, and if I click on transact, it will work because my address currently, which the address that I'm calling from, this address is the teacher here. You can see here. Now let's call from another address. Let me select the address second and call this as, let me change this as hacker and call this. So it will return, it will just throw an error saying that not a teacher. Okay, because address is false, so it won't allow them. But can I read the data with any address? Yes, you can. So let me just try to get the attendance of Pawan again here. If I call it, you can see it says true because we just added the data. Okay, now let's update the raining status. So here I'm going to say true, update rain. You can see we got it, right? We got it. So this is this is about the basics of Solidity, guys. There is not much here, I know that, but you'll be learning a lot about struct. You'll be learning about many of the things like sending tokens, transferring tokens, re-entrancy guard, all these things tomorrow when we start with the crowdfunding contract. Okay, I don't want you guys to get overwhelmed with everything, all the details and concepts on Solidity, so I just kept it very simple, really simple, like bare bone what do you say, version of fundamentals of Solidity. Okay, so tomorrow when we start with the crowdfunding contract, we'll be looking at the struct data type where we can actually store all the project details and everything. We'll see how to map struct with project IDs. We'll see how to register the products, how to fund the project, how to get the withdraw the funding and everything. Okay, so till then, thank you guys, thank you so much for joining. This was a really short session. This was a really basic session. So tomorrow let's meet again at the same time, and then we'll handle we'll look into so many things, like we'll start with the contract, the crowdfunding contract. Okay, and going further we'll start developing the React UI, and then we'll integrate the crowdfunding contract to it. Okay, so thank you guys, thank you so much, bye bye, take care.